imagine you're on this spacecraft, and it's like whooshing towards the sun
Oh, wow.
at an unbelievable speed. Like it's going so fast,
Yeah.
And you're on this mission to figure out all the secrets of our nearest star.
Yeah.
This big ball of plasma that's been like the giver of life and energy for billions of years.
Amazing.
Welcome to Cosmos in a Pod, the Space and Astronomy series.
Yeah.
Please like, comment, share, and subscribe.
Yes.
So we've all seen the sun a lot, right? I mean, it's like there every day.
Every day.
But how much do we really know about this, like this big powerhouse in the sky?
Yeah, it's an interesting question.
Today we're going deep into the heart of the sun,
Ooh.
exploring its structure, all the mysteries it holds, and the incredible missions that are helping us unravel its secrets.
It's going to be a fascinating journey.
I think so.
One that's full of surprises.
Okay.
You see, the sun, it's not just this like static ball of fire just hanging there.
Right.
It's dynamic. It's always changing.
Right.
With layers upon layers of activity and complexity.
Okay, so let's break this down a little bit. When we look at the sun, what are we really seeing?
Well, what you see is the photosphere,
Okay.
the sun's visible surface.
Right.
But it's not a solid surface like we have here on Earth.
Oh, okay.
It's a layer of crazy hot plasma, about 6,000 degrees Celsius.
Wow.
And that's where most of the sun's light comes from.
Okay, so it's kind of like the tip of the iceberg.
Exactly.
That's a whole lot more going on underneath.
Oh, yeah, absolutely. Beneath the photosphere, there's this vast and really intricate interior,
Wow.
starting with the convective zone.
Okay.
This is where hot plasma rises, cools, and then sinks back down. It creates this churning motion that carries energy up towards the surface.
This is like a giant boiling pot constantly stirring.
Yeah, that's a great way to think about it.
I like that.
And as we go deeper, we get to the radiative zone. This is super dense, and energy can take like hundreds of thousands, even millions of years to travel out.
Wow, that's a serious traffic jam of energy.
Yeah.
Okay, so we went from the photosphere through the convective zone, and now we're in the radiative zone.
Mm-hmm.
What's next? What's at the very heart of the sun?
At the very center of it all is the core,
Okay.
the sun's nuclear furnace.
Mm-hmm.
Here, the pressure is immense, temperatures over 15 million degrees Celsius.
It's hot.
And this is where hydrogen atoms fuse into helium, releasing all that energy that powers the sun.
It's mind-blowing to think that that process, that fusion, has been going on for billions of years.
I know.
And it'll keep going for billions more.
It's incredible, the power and the longevity of our star.
Yeah.
But you know, it's really fascinating.
Huh.
All that energy made deep within the core,
Yeah.
it has to travel through all those layers we talked about before it gets to us here on Earth.
So it's a journey of epic proportions
It is.
in terms of both distance and time.
And as we've learned more about the sun's interior, we've run into some really puzzling questions.
Wow.
Yeah, and one of the biggest is the coronal heating problem.
Oh, yeah, I've heard of this.
Yeah.
It's the mystery of why the sun's outer atmosphere, the corona, is millions of degrees hotter than the surface.
Right.
It seems kind of counterintuitive, doesn't it?
It really does. You'd think the further you get from the heat source, the cooler it would get.
Right.
But the sun, it's the opposite.
Yeah.
The corona, that wispy outer layer, can reach temperatures of over 1 million degrees Celsius.
Wow.
While the photosphere, where all that energy starts, is only around 6,000 degrees.
So how do scientists explain that?
Well, there are a few theories.
Okay.
Some think that powerful magnetic waves made in the sun's interior are funneling energy up into the corona.
So like a cosmic elevator.
Exactly, lifting energy from the surface to that outer atmosphere.
I like that.
Others believe that tiny bursts of energy, called nanoflares, are constantly erupting on the surface,
Okay.
and they're collectively heating the corona.
It's like a billion tiny explosions going off all the time.
It is. And then there's the solar wind, a constant stream of charged particles shooting out from the sun, which might also be contributing to the heating.
So there are a lot of possibilities.
Yeah.
But we're still working on the whole picture.
We are. It's a complex problem, one that needs a really deep understanding of the sun's magnetic fields, plasma dynamics, and how energy moves around.
Yeah, it's amazing to think that this object, we see it in the sky all the time, still holds so many mysteries.
I know, that's the beauty of science. The more we learn, the more we realize how much more there is to discover.
Right.
And the sun, our closest star, is a constant source of wonder and intrigue.
Absolutely. Speaking of discoveries, haven't we sent probes to actually study the sun up close?
We have.
Yeah.
One of the most amazing missions is the Parker Solar Probe,
Yeah.
a spacecraft that's getting closer to the sun than any other before it.
Wow. How close are we talking here?
The Parker Solar Probe is flying through the sun's corona within a few million kilometers of the surface.
That's insanely close to a star that's over 100 times the diameter of Earth.
It is. And it's moving at an incredible speed, over 600,000 kilometers per hour. It's the fastest human-made object ever.
Why does it have to go so fast?
That speed is vital for the probe to survive.
Oh, okay.
It lets it dip in and out of the corona really quickly,
Got it.
minimizing its exposure to the intense heat and radiation.
So like a daredevil skimming the surface of, like, a raging inferno.
That's a great way to put it.
I try.
And even with those insane conditions, the Parker Solar Probe is sending back some incredible data,
Oh, wow.
giving us views of the sun's corona and solar wind we've never seen before.
What kind of, like, insights is it giving us?
Well, it's seen these strange zigzag patterns in the sun's magnetic field.
Okay.
They're called switchbacks.
Switchbacks.
Yeah, and they might help explain how the solar wind is generated and speeds up. So it's basically rewriting how we understand the sun. It is. And it's just one example of the incredible missions that are helping us unlock the secrets of our nearest star.
Yeah.
It's really amazing what we're learning.
So we've been talking a lot about the Parker Solar Probe.
Yeah.
And, like, it's amazing, right? All the engineering that lets it get so close to the sun.
It's incredible.
But it's not the only tool we have for studying our star, right?
No, none at all.
So what other ways do scientists use to unlock the sun's secrets?
You're right. The Parker Solar Probe is amazing, but it's just one piece of the puzzle.
Right.
We've got a ton of instruments, both on the ground and up in space,
Okay.
giving us this, like, multifaceted view of the sun.
So it's like having a team of detectives, each with their own specialty,
Yeah, exactly.
working together to solve the case.
Some of our most powerful tools are actually ground-based solar telescopes.
Okay.
These telescopes have really fancy filters and instruments
Right.
that let us observe the sun in all these different wavelengths of light. It reveals details we could never see with just our eyes.
So, like, what kind of details are we talking about?
Well, we can see sunspots,
Okay.
those dark, cooler patches on the surface we talked about earlier.
Yeah.
We can also see prominences,
Okay.
these huge loops of plasma that stretch out from the sun, sometimes for hundreds of thousands of kilometers.
I've seen pictures of those. They're incredible.
Oh, yeah.
They look like fiery arches just hanging in space.
They are quite a sight.
Yeah.
And then there are solar flares, those sudden bursts of energy
Yeah.
that release radiation across the entire electromagnetic spectrum.
So ground-based telescopes,
Mhm.
they give us that close-up look at the surface
They do.
and all the crazy events happening there.
But to really understand the sun, we have to go beyond Earth's atmosphere.
Okay.
And that's where space-based observatories come in.
Like the Parker Solar Probe.
Like the Parker, yeah, but others too. One of the most important is the Solar Dynamics Observatory, or SDO. It's been orbiting the sun since 2010.
Okay, and what makes SDO so special?
It's like a solar watchdog,
Okay.
constantly watching the sun in tons of wavelength.
Wow.
It takes pictures every few seconds,
Seriously?
giving us this constant stream of data about what's happening.
So it's like having a live feed of the sun's most exciting moments?
Yeah, exactly.
That's awesome.
And SDO has given us so much information about solar flares, coronal mass ejections, and how the sun's magnetic field works.
So it's like we have front row seats to the sun's biggest show.
And then we have SOHO, the Solar and Heliospheric Observatory.
Okay.
It's been watching the sun from space since 1995.
So what does ESO focus on?
Well, it's a multi-purpose observatory,
Okay.
but one of its big contributions is in helioseismology.
Hold on. Helioseismology. What's that?
It's the study of the sun's interior, but using sound waves.
Why?
Kind of like how geologists use seismic waves to study the Earth's insides, helioseismologists use sound waves to map out the sun's structure.
So we can actually see inside the sun using sound.
We can.
That's wild.
By looking at the patterns of those sound waves, we can learn about the sun's density, its temperature, what it's made of at different depths.
So it's like taking an ultrasound of the sun.
Yeah, that's a great analogy.
It's revealing all these hidden layers.
And ESO, it's totally revolutionized how we understand the sun's interior, helping us see the processes that drive all that activity.
So it seems like we have this impressive toolbox for studying the sun.
We do. And these tools are always getting better and more precise.
Right.
giving us more detailed and insightful views of our star all the time.
It's not all just for scientific curiosity, though, right?
Yeah, no, definitely not.
I mean, understanding the sun has real implications for us here on Earth.
Absolutely. The sun is not just some faraway object.
Right.
It's this powerful force
Yeah.
that can have a massive impact on our planet and everything we use.
We talked about solar storms before and how they could mess up our power grids and communication systems.
Right. And those storms, they start on the sun. And they can travel so fast through space, reaching Earth in just a few hours or days.
So the more we learn about the sun and how it acts, the better we can prepare for those storms.
Exactly.
And maybe even lessen their impact.
By monitoring the sun's activity and creating better forecasting models,
Okay.
we can give people early warnings about potential storms.
So it's about understanding our star, not just for the knowledge itself, but for our own safety.
It is. The sun gives us life and energy, but it can be dangerous too.
Right.
By studying it carefully, we can learn how to live with it, using its benefits, and protecting ourselves from any harm.
Okay, so we've talked about, like, the structure of the sun, the different layers and all the amazing missions helping us understand it better.
Yeah.
But what about all those crazy events we see on the sun?
Right.
Like those huge bursts of energy and, like, eruptions of plasma. Can we, like, zoom in on those a bit?
Oh, definitely. We're talking about sunspots, solar flares, coronal mass ejections.
Right.
They're not only visually stunning, but they give us clues about the sun's magnetic field and how it affects us here on Earth.
Okay, so let's start with sunspots.
Yeah.
I remember seeing pictures of those as a kid, those dark patches on the sun. What are they exactly?
Imagine like these massive magnetic knots on the sun's surface. They're so strong, they actually stop the heat from below from getting to the surface.
Oh, wow.
So a sunspot, it's actually a region that's cooler than its surroundings. That's why it looks darker.
So it's like a magnetic traffic jam kind of blocking the heat?
Precisely. And these sunspots can be enormous. Some are even bigger than the entire Earth.
That's huge. But they're not just like sitting there, right?
Yeah.
They change over time.
You got it. Sunspots go through these cycles of activity. We call it the solar cycle, lasts about 11 years.
Okay.
And during this cycle, the number of sunspots, it goes up, it goes down. And that affects how often we see other solar events too.
Like you mean the solar flares and coronal mass ejection?
Exactly. Think of sunspots like the epicenters for all these powerful events.
Right.
You know those tangled magnetic fields we talk about?
Yeah.
Sometimes they snap.
Oh, wow.
And when they do, they release just this massive amount of energy.
And is that when we get a solar flare?
That's it. A solar flare, it's like this sudden flash, this burst of radiation across the whole electromagnetic spectrum, from radio waves to X-rays and gamma rays.
Wow.
And if a really strong flare is pointed right at Earth, well, it can mess with our radio communications, GPS signals, even damage satellites.
That's intense. Okay, so what about coronal mass ejections, the CMEs?
Yeah.
They sound even more powerful.
Okay, picture this. A billion-ton cloud of charged particles, just this giant bubble of plasma launched into space at crazy speeds. That's a CME.
Whoa.
It's like a solar tsunami caused by those snapping magnetic fields.
So it's like sunspots are the warning signs. Like,
Yeah.
heads up, something big's about to happen.
Yeah, you could say that. Sunspots are where the magnetic activity is really high.
Right.
And all that activity can lead to these explosive events that can definitely affect us here.
It's kind of incredible and a little scary how these little dark spots on the sun can cause so much stuff.
It really shows how connected everything is in our solar system.
Yeah.
The sun's activity, it ripples through space, affects everything in its path. And the better we understand these events, the better we can protect our tech and ourselves.
This deep dive has been amazing. We've gone from the sun's core all the way to its corona. We've uncovered some secrets and seen just how powerful it is. Any final thoughts for our listeners?
I'd say remember this. The sun isn't just some distant object. It's what sustains life on Earth, but it can also be dangerous.
Right.
By studying it, getting to know it, we can learn how to live with it, appreciate its beauty, but respect its power too.
That's a great point. Thank you so much for taking us on this incredible journey to the sun.
You're welcome.
And listeners, we hope you've enjoyed learning all about our nearest star. If you want to keep exploring space with us, be sure to follow and subscribe to Cosmos in a Pod and our YouTube channel. Until next time, keep looking up and keep wondering.